the egg. Initially, bicoid and nanos are pumped into the egg by the nurse cells. How do they end up in the right places? They end up in the right places because there are targets in the surface of the egg already there before the pumping takes place. And the bicoid sticks basically to this target, and the nanos sticks to that target. So the head and tail were already determined before these products were pumped into the egg. If we compare an embryo to a house, what do we need to build a house? We need building materials, we need assembly instructions. Building materials would include the wood and the bricks and the pipes and the wires and so on, the shingles. If I were to give everyone in this room an identical set of complete set of building materials, and then you were all go off on your own somewhere where you couldn't see what other people were doing, chances are I would get as many different types of structures as there are people in the room. The materials alone do not determine the floor plan. And yet DNA, the information that it does provide, is concerned mainly with providing the building materials. The assembly instructions are also important because if you build the roof before you build the foundation, you're going to have a serious problem. And some of those instructions are also in the DNA. Look at the Hox genes, for example. What is not in the DNA is the floor plan. And yet this is the all-important factor that we need to deal with if we're talking about animal body plans that appear in the Cambrian explosion. Conclusions, so we can get to the Q&A. First of all, the floor plan of the embryo is at least partly in the form of spatial information that precedes DNA differentiation. There is evidence, which I haven't gone into here for lack of time, that at least some of this spatial information is inherited independently of the DNA. Oh, sorry. Therefore, and this is the bottom line, DNA mutations alone cannot change the body plan. So even if we had enough time in the fossil record to change a terrestrial mammal into a whale, even if we had enough time to find a new protein fold, even if mutations early in embryo development could survive, none of this is going to explain evolution in neo-Darwinian terms because DNA mutations alone cannot change the body plan. And to illustrate this, I'll come to my last slide, which hopefully will be the one you remember. And this is based on experiment in fruit flies, in worms, in zebrafish, and now in mice. We can modify the DNA of a fruit fly, in this case, in any way we want, and there are only 3 possible outcomes. There have been no observed exceptions to this list. We either get a normal fruit fly that survives in spite of the mutations. Often we get a defective fruit fly, and perhaps even more often we get a dead fruit fly. And that's it. Thank you.
We're obviously critiquing tonight the standard neo-Darwinian theory of evolution. There are other ideas about evolutionary theory out there, people proposing things like self-organization. There's a whole group of scientists who are not advocates of the theory of intelligent design. There are evolutionary biologists called the Altenberg 16, some leading figures in the field like Lynn Margulis and Will Provine, Massimo Pigliucci, and others who are saying neo-Darwinism is dead, and it's time for a new theory of evolution. And so we welcome that conversation about what that theory should look like. The gentlemen you see here tonight are advocates of the theory of intelligent design, which was explained in part at the end of the film. And, but we think an important first step in scientific progress is dispensing with ideas and theories that no longer work. And we think clearly neo-Darwinism should fall in that category. But if you'd like to talk about our positive alternative agenda, that's something we're very prepared to talk about tonight in Q&A, or anything else you would like to discuss. And we'll start there. Do we have a mic or something that people could come up and... A roving mic? Yeah, good.